Hello everyone, my name is Vladislavs Fots. I am from Latvian transmission system operator, AST, and together with Jonas Zemaitaitis, we are going to tell you about our experience on nodal market modeling and how we created a common market nodal model and evaluated our cross-border from different perspectives. So why we needed this cooperation between both countries. In TNDP 2022, it showed us that in 2040, Latvia and Lithuania need additional 500 megawatt capacity between us. And after that, we start seeing how we can evaluate this by ourselves and look at the future, let's say. And we see opportunity for collaboration. And we had main two reasons. First of all, to see how accelerated integration of the renewables can impact our network, what can happen. And since it is not a model, the picture is more broad and more interesting, as well as we wanted to evaluate our cross-border from different and answer different questions. So when we need additional capacity between the two countries, where we should put it in real life, and also how much we need it. Then we as well has secondary targets. Previously, we never had any market model which is exactly the same as the network one, and together we could prepare it. And since both TSOs are using PLEXOS, it is quite easy to work on the common model and do everything. As well as we wanted to evaluate a curtailment, see how it works if we distribute across the grid all the wind, solar power plants. Yeah, and about the renewables in both of our countries. During the last few years, we have seen a lot of interest from the developers to add additional capacity to our grids. In Latvia, in last year, we had already around 200 megawatts of solar and wind capacity. On the other side, in Lithuania, they already had, or now already has around 1.5 gigawatts. And we also added some projectiles to show you 2030. So in Latvia, we are looking to have around 2.6 gigawatts of installed capacity, and 500 of which will be offshore wind. On the other side, Lithuania has much more bigger targets with 11.5 gigawatts, and 1.4 will be from the offshore wind. Then about how we created our model. We prepared it for the 4 different time horizons, 2030, 35, 40, and 50. We took ERA 2023 model as a base one, and then we reduced it to Baltic Sea region. So we left in the network only Baltic countries, Nordics, and Germany and Poland. We didn't include any countries beyond them. Why? Because they are not impacting results almost at all in our country. So to optimize the system and reduce the simulation time, we decided to not include them in our model. As well as after the model was ready, we executed the simulation for a few different climatic years and haven't seen any impact on the results. Since then, we decided to use just one average climatic year and execute all simulations with it. About the nodal model, how we go from the just one node per region to nodal setup. In the picture, you can see Latvia and Lithuania and 330 kV network. And we added around 55 330 kV nodes, almost 300, 110, and 500 lines and transformers. Transformers was built in the network as a line between 2 voltage levels. Then about the wind and solar generation, we have it across the whole network. And to make it more realistic, we placed it based on our developers' applications where they want to build a new res generation. As well as we added to the system some offshore wind in both countries, electrolyzers, and Lithuania also added a lot of battery systems to their network. Then about the pros of the nodal market model. First of all, since we previously in the market model see only one line between 2 regions, and when you expand it to the nodal model, you can add additional 4 lines in our case, and we can see which lines are loading them more and where we should focus in rebuilding our cross-border, as well as we were able to see our internal lines, how they are overloading, what is happening in the system, where we lack some capacity or having bottlenecks in our system. Then compatibility with the grid. Usually, when you have this nodal, when you have the regional market model, you have, let's say, for 1 hour, 2 gigawatt of solar. And for network models, it's quite hard to distribute them correctly across the network. Therefore, we extracted all data based on the nodal level, all generation, as well as consumption, and then placed all information to the network model and executed there some other simulations. And overall, the result precision is quite good. So we were able to see curtailment on the different levels. Let's say we have 2 nodes. On one node, 50 megawatt solar power plant is curtailed during the year by 5%, on the other node by 30%. And as well as how electrolyzers impact the system. And we also can see the price imbalances at each node and what is happening in the system. And now I want to give the word to Jonas to speak more about the study itself and what we were doing.
Right, so thanks, Vladislavs. I will run through the stages of our study. We started off with preparing a reference model, basically to try and validate our nodal setup in a market model for the year 2022. It took us quite a lot of going back and forth until we were happy with the reference scenario, but from there we could start to build our future market model. So as Vladislavs mentioned, our TSOs are mainly interested in 2030, but also other target years. So we decided to go with 4 different time horizons and try to model all of them based on our best estimates. Running a base case for all of them, also making a couple of adjustments allowed us to move towards introducing the different scenarios that we are interested. So basically the reinforcement options of our cross-border. So as you can see from the table at the bottom, there are 3 different reinforcement options as option 1, option 2, and option 4. And the other options are just combinations of different single projects. So as you can see, we ended up with 6 different scenarios for each year because we also have the base case. And that adds up to already 24 market models that we needed to run. And having run them and more or less being happy with the market setup, we then needed to run the network model, as Sebastian mentioned before. When network guys see the results, start investigating, then they start blaming the market modelers. So we had to do this, of course, a couple of iterations until everybody was happy. And we selected to go with this snapshot approach, where for each model we pick out 7 different snapshots that basically represent the more critical scenarios or critical situations in the system. So yeah, we ended up with a lot of snapshots, 168. So I'm very glad that my colleague from network modeling is good at Python coding and was able to use all the data that we produced. Right, so as I mentioned, we went a little bit back and forth, but at the end we managed to estimate which of these options was the best and which we should maybe eliminate in the future. So maybe going back to this topological map, you can see that we decided to concentrate on the western part of our region. That is because all those huge numbers of renewables, hydrogen that's being planned. All of them pretty much is being concentrated on the western part of our region. And I think on the other two lines that we have on the eastern side of our region, there are some other plants, and the most eastern line is actually some more legacy line. So looking at the outcomes of our collaboration, we were able to produce a nodal market model for four different target years. Of course, we had the opportunity to analyze a lot of data from generation, demand, the cross-border and internal flows per node, which was very useful and was more or less the first opportunity for us to investigate it on such granularity. And this allowed us not only to answer our question, but also gain additional insight for such topics that are, I think, most talked about in TSOs are the renewable curtailment and the hydrogen production and how it could be modeled. So as you can see from the map, we identified that the biggest potential for reinforcements could be on the western, most western line, but interestingly not only that, but also internal line reinforcements are needed to reach the full potential, let's say. And we with Vladislavs say that no modeling exercise is finished until you write down some lessons that you learned from this exercise, because there's always some opportunity to improve. And I would say that one of the most important lessons was that there is a completely different economical evaluation than we was used to, because we used to run regional models, and now you have to evaluate hundreds of nodes. And of course, previously, if you received, let's say, 10 questions or 15 questions about your model, now you can raise the same questions for multiple nodes already. So it's quite complex to analyze the data. And also, if you want to adjust something, then it is a little bit harder to implement simplifications to the model, which I guess all modelers do. Of course, then there's the two major topics that we're interested, but that they were not the main focus of this study. So how we are modeling electrolyzers, we had to make assumptions, especially for the further years, especially like 2050, where we have huge ambition, but for now, not a lot of concrete plans. So I would say that in the future, we will try to tackle this topic maybe together also. And from a renewable viewpoint, I would say that there was a challenge that we have a different regulation, and there needs to be some more coordination between us on how to implement it into the model, because there is, of course, renewable curtailment sharing, since our systems are well integrated, and integrating them more might raise more questions if we don't align on the regulation. So the results, as I mentioned, we managed to narrow down the list of our potential reinforcement options by building a nodal PLEXOS market model. It is aligned with our network model, which allows us for future studies that we can perform together or even separately, retaining the information that the other TSO provided us. We can investigate other topics that are very interested for the discussions that are happening in the TSOs. And I think finally we started this path together that allows us to improve this model in the future and tackle more complex questions and maybe answer some of the questions that are rising up. So thank you very much, and maybe you have any questions for us.
All right, any questions? Here.
Thanks. Thank you for the presentation. Very interesting. Put a nodal model in PLEXOS, firstly. I'm Alberto Mazzoncini from Litgid, and my question is, you use deeply the insights you take out from the results of the nodal, right, to assess the curtailment. But did you consider n-1 since you are playing with nodal? And if it's yes, which candidates you select?
Yeah, in the market model, we haven't had any contingencies or n-1 analysis, but in the PSSC, when we extracted all these snapshots and created these 170 cases, after that, we had around 30 different contingencies in our networks. So one by one, they was disconnected and evaluated what is happening in the network. So you have seen this map with the red lines. Basically, in the case with the contingencies, all the western part was red because of the overloadings in some lines due to lack of the capacity that's caused by contingency or n-1 of specific line.
Any other questions? Nope. All right, well, we're back. Oh, no, we do have a question.
Just on the point you made on simplifications being harder, can you give us a few examples of why that was the case?
Usually when we model, we don't, by simplification, what I meant, usually we model only including Germany. We don't include, let's say, France. Why? Because it's quite far away and it's almost don't have any impact to our results. But if you add so huge country to the model, it increase the computational time of the PLEXOS. And we just didn't see any reason for that to include it.
And maybe I can add on the point that we had to make simplifications in the nodal setup that previously maybe we didn't think about when modeling regional. Was that, for example, with hydrogen, we had to make simplifications that all hydrogen production units are the same, which definitely will not be the case in the future. Every actually unit will be quite unique based on their use cases, probably. And I think we had to do some assumptions on the locations where we place them. While there are no exact plans now for that far away targets. So yeah, I think in general, just more assumptions and it's a little bit harder.
All right. Okay, everything starts back at 4:30 and we're in a coffee break now, between now and 4:30. So thank you very much.